Hello everyone, welcome back to my YouTube channel. So today we are going to solve day 16 problem of this month on LeetCode. Before starting, if you guys haven't subscribed my YouTube channel yet, then please go ahead and subscribe it. Now without any delay, let's get started with today's problem. Problem number 2594. Minimum time to repair cars. Okay, so now let's read the problem statement first. You are given an integer array ranks representing the ranks of some mechanics. Okay, so see this example number one. So we have this ranks array, okay, which is representing the ranks of some mechanics. Okay, ranks of I is the rank of the ith mechanic. A mechanic with a rank R can repair n cars in R into n square minutes. Okay, so a mechanic with rank R can repair n cars. N is the number of cars in R into n square of minutes. Okay, rank into the number of cars square. Okay, you are also given an integer cars representing the total number of cars waiting in the garage to be repaired. Okay, so see this cars is equal to 10. That simply means that there are 10 cars that needs to be repaired. Okay, now we have to return the minimum time taken to repair all the cars. Okay, so we have to return the minimum time taken to repair all the cars. Okay, so note that all the mechanics can repair the cars simultaneously. All right. Okay, now see this example number one. So we have these ranks 4, 2, 3 and 1, and total cars are 10 here. Okay, so now here if you see why we are getting output 16, so see the first mechanic will repair two cars. Okay, so this is first mechanic. Okay, so time required is rank, okay, this, and he is repairing two cars, so here 4 into 2 into 2. Okay, so 16 minutes. Same way he is repairing two cars, he is also repairing two cars. Okay, the second mechanic will repair two cars, the time required is 2 into 2 into 2, that is 8 minutes. This mechanic is also repairing two cars. Okay, the third mechanic will repair two cars, the time required is 3 into 2 into 2, 12 minutes. Okay, and this mechanic is repairing four cars. Okay, the fourth mechanic will repair four cars, the time required is 1 into 4 into 4, that is 16 minutes. Okay, it can be proved that the cars cannot be repaired in less than 16 minutes. Okay, so now see why we are getting this 16. Okay, so in this way we are getting the output 16. Okay, as per this explanation. Okay, now see how. Okay, so here first of all, if you see a mechanic with a rank R, okay, see this point, a mechanic with a rank R can repair n cars in R into n square minutes. Okay, so the person with a lower rank, okay, with a lower rank, he can repair more number of cars in less amount of time, right? Since rank is just for 1, okay, rank is just 1, so if he repairs, let's say, 4 cars, then how much time he is going to take? He is going to take 16 minutes. But same, let's suppose there is another mechanic with the rank 4, okay, and he also repairs 4 cars. Okay, then what is the amount of time he is going to take? 64. Okay, so a person with a lower rank can repair more number of cars, okay, in less number of minutes, right? Because of this formula, right? R into n square. Okay, so this is one point. Okay, so this problem essentially boils down to distributing the cars optimally among the mechanics so that the maximum repair time, okay, is minimized. Okay, maximum repair time, we have to minimize that. Okay, maximum repair time, maximum repair time needs to be minimized. Okay, so in this way we have to distribute the cars, right? So this problem distributes the cars optimally among the mechanics so that the maximum repair time, okay, it should be minimized. So where this is hinting, okay, so yesterday in yesterday problem also I have discussed that whenever we have something like maximize the minimum, or minimize the maximum. Okay, whenever any problem hints towards this, okay, always think about binary search first. Okay, binary search. Okay, now this, sometimes whenever there is a optimal approach, sometimes we think about DP as well. Okay, so now why don't we need to apply DP here? Okay, why can't we don't apply DP here, right? So there is a reason. So you can find out the reason here. The constant size cars is 10 raised to power 6. Okay, and the ranks dot length is also 10 raised to power 5. Okay, so in this problem, ranks dot length is 10 raised to power 5. Cars can be up to 10 raised to power 6. Okay, a typical DP solution, okay, would require a state representation like this: DP of mechanic. Okay, this is mechanic, and here car. Okay, so this is how you are going to represent DP, right? DP representation. So time complexity would be O of n, okay, number of mechanics into cars. So that simply means, which in worst case is it's going to be 10 raised to power 5. Okay, see here 10 raised to power 5, and here cars is 10 into 6. Okay, into 10 is equal to raised to power 6. So you are going to get 10 raised to power 11. Okay, so this is for too long to be computationally feasible, right? So a good approach here can be to use the binary search, as it provides more natural way to minimize the maximum time, right? That is what we are doing here. We have maximum repair time, we have to minimize, right? So we have to, I can say, we have to minimize the maximum repair time, right? Okay, all right. So you are clear, right, why we don't need DP? Because whenever deciding on approach, always check the constraints first. All right, so here the C and cars are very large, right? So DP is not feasible. Okay, instead binary search, greedy or two pointers are more likely to work in such cases, okay, where the constraint size is very large. Okay, so this is one point here. All right, okay, clear, done. Now here this is good. All right, so now we are talking about this minimize the maximum repair time, right? So now see what I'm going to do here. All right, so here we can also do one thing, right? We know that we have to apply binary search now. Okay, so now here see, this is example only 4 2 3 1 and 10. Okay, 4 2 3 1, and here we have number of cars 10. Okay, so now you are clear with one point, that the person with lower rank, okay, he is going to repair more cars in less time. Okay, so here let's suppose this person's one only. Okay, he repairs 10 cars. Okay, total cars is 10. So 1 into 10 is equal to 10, 100 minutes, let's say, right? This is the answer, right? So now let's suppose a person or mechanic with this rank, he wants to repair all the 10 cars by himself. So then he is going to take 400 minutes. Okay, done. Okay, so here I can do one thing. I can take so now see here, what we have to minimize, we have to done the minimum time taken to repair all the cars. Okay, so we can apply the binary search on the time taken. Okay, so here let's do one thing, let's take minimum as 1. Okay, done, and maximum let's take this only. Okay, this has a maximum. Okay, so I will say this is a maximum. Okay, 1 into 10 into 100, max is equal to 100. All right, so don't take this 400, because we still know that person with lower rank can fix all the cars in this minutes. Okay, so let's take this as maximum. So we can actually lower this from 100, this 100 minutes we can still reduce the time, okay, by distributing the cars, right? like two here, two here, two here, four here, we get around 16 minutes only. Okay, but here I can take this as a max. Okay, so if to the lower rank I assign all the cars, okay, I will take that as maximum. All right, so here also one more thing you can do. So here your array is not sorted, right? So you can sort this array as well. Okay, so once you sort this array, you will get like this 1 2 3 4, and then you apply here rank into uh, the number of cars into number of cars 100. Okay, this is one way. Or if you don't want to sort the array, that is also fine. Okay, that is also fine. If you don't want to sort it, instead of that you can simply select whatever the value that comes here. Okay, so any value which comes at this, it is either the smallest or maybe larger, no issues, we still cover this range 1 to 100. So if there is 4 of here, then we will cover 1 to 400 range. Okay, so here if there is some other rank, like suppose 2, then 2 into 10 into 10, 200 range. So that is also fine, we need just 100. Okay, so for to get the 100 we have to sort the array, but I don't want to sort the array in, because here also then I will consume over and login time complexity. Okay, if I apply arrays dot sort this array. Okay, so instead of this I will just pick whatever the first value I have. Okay, so it doesn't matter because I'm going to check then 1 to 100, then I will check 1 to 400. Okay, no issues, I will check 1 to 400, no issues, done. Okay, so now here this is the range, right? So let's take 1 to 400. Okay, instead of sorting the array, done. Now here how you apply the binary search. So you apply binary search like this now, while your min, okay, is less than max, done. Okay, so now inside this what you do, you have to calculate the mid. Okay, so how you calculate the mid? So here you calculate the mid like this, mid is equal to min plus max divided by 2. Okay, this is how you calculate the mid. So now you are going to get the mid as 50. Okay, right now your mean is 1, max is 100. So 1 plus 100 divided by 2, you are going to get this as 50. Okay, so now with the 50 I will see how many cars I can repair. Okay, so this is what we have. Okay, so now how I'm going to calculate 4 3 2 3 1, this is what I have, and total number of cars is 10. Okay, so now my mid is 50. So I will see with 50 minutes how many cars I can repair. Okay, how many cars I can repair in just 50 minutes. Okay, so here one mechanic, okay, a mechanic can repair n cars, okay, in how many minutes? In r into n square minutes. Okay, a mechanic, here understand it carefully, a mechanic can repair n cars in r into n minutes. Okay, this is given problem statement. So now I am trying to find out how many cars, okay, this person can repair in 50 minutes. So here that I will get using this formula. Okay, this value, it should be less than equal to 50. Okay, or instead of 50 I can say mid. Okay, general formula I can say here mid. Okay, done. So number of cars I have to find, that simply means n value I have to calculate. Okay, so r into n, that will give me minutes. Okay, and these minutes should be less than equal to mid. Okay, I can write it like this as well, n square less than equal to mid divided by the rank. Okay, and I can write it like this, n it should be less than equal to square root of mid divided by r. Okay, so this is the number of cars. Okay, this is the number of cars. So using this formula I can calculate the number of cars that this person can fix. Okay, let's say a cars, and the number of cars that this person can fix in 50 minutes, the number of cars that this person can fix. So let's say c number of cars he fixed, let's say he fixed d number of cars in 50 minutes. Now after that I will check the summation of all this. Okay, so he fixed a cars, he fixed b cars, he fixed c cars, he fixed d cars. So I will do the summation of all this. So in the summation of this, okay, if the summation of this greater than is greater than equal to the number of cars we have, that simply means that in 50 minutes I am able to repair all the cars here, right? If the summation is okay, if the number of cars that are repaired in 15 minutes by all these mechanics is greater than the actual cars value, right? That simply means, okay, so initially it's 100, okay, 100, then we get mid as here, okay, 50. Now I see in 50 only we are repairing more number of cars, okay, than the assigned 10. So I have to check then in this range, okay. Okay, this is the binary search approach, right? We just split this interval in half every time, okay. So every time our search interval reduces to half, right? So now if in 50 minutes I repair more than 10 cars, so let's check in this range. In this range I'm going to check. So for that, what I'm going to do, my mean will remain here only, and my max is going to update to mid, okay. So I will set it to max now. So now in this range I will check next time, okay, how many cars I can repair. So I will get mid as 25. So in 25 minutes I will check how many cars I can repair. So if I can repair more number of cars in just 25 minutes, then I have to reduce the search interval. I have to check here, okay. So again this 0, this is going to remain 25, and this mean is 1, okay. We take 1 initially, so again you get 13 here. All right, so next time if you don't able to repair all the cars, okay, 10 cars in the 30 minutes, okay. So let's say we are getting this sum value less than number of cars, so then we have to search in this interval. So if we want to search in this interval, so in that case I'm just going to update my mean as mid plus 1, okay, mid plus 1. So from here I will check, okay, in this range. So here, from here I have to again split the search interval in half, okay. This is what we need to do, and in the end I will just simply return the mean, okay. So that's what we need to return, right? So now let's write the code for this one, okay. So it's very simple, okay. So you just have to find out this logic, okay, first, and you should know why we can't apply dp because of constant size, all right. And then you should know how we are taking this min and max, okay. That's an important thing, okay. And yeah, all right. And since this is a binary week, so I think most of you guys are first checking binary search only, okay, right? Because in this week actually from last 5 to 6 days we are getting only binary search problems, okay. So I will attach the playlist link to all the binary search problem, okay. So if you want all the binary search problem, you can just go over that playlist, find out the problem, solve it by your own first, okay, and then watch the video if necessary. But first try to solve by your own, all right. I will attach the link to the binary search playlist, okay. So now let's write the code, all right. So here code is going to be very simple, very few lines of code, very few, right? And here see, size is long, okay. We have to return type is long, and the values can be very large, okay. Ranks dot length is 10 to 5, okay, and cars is 10 to 6, okay. And if I am doing the multiplication like r into number of cars into number of cars, then this value could be very large, right? So let's use long only for min and max, okay. So long min is equal to 1, all right, okay. And long of max should be equal to the, you can say whatever the first rank we have. So this ranks of 0 actually is an int type, right? All the integers are there. I am multiplying this with cars is also integers. I am multiplying it with cars only, cars is also integer. But here see, cars can be 10 to the power 6, okay, and I am doing the multiplication, so it will go very big enough, okay. So first let's say if I calculate this, so value could be very large, but if this is int, then definitely I will get some precision type issues, okay, precision type issues. So I can, while multiplying it itself, okay, I will just change it to long, okay. I will use long here, okay. So I will get the output of cars into cars in long type only, and then I will multiply with the rank 0. I will again get long only, and I will store that in max, okay. That's why we have to write long here, all right. Now simple binary search approach. So while min is less than max, okay. Now here many people ask why we are writing min less than max, or when we should write min less than equal to max. So actually you don't have to worry about this, okay. Just try this, okay. Try to solve this question on paper first and see, will we get the answer, will we get the perfect answer with min less than max, okay, or not, all right. So there are many way. So if you use, let's say, min less than max, okay, so in some cases you may use a low as mid plus 1, okay, and high as mid minus 1. Sometimes what you do, you get write min less than mid, okay, so you write low as mid plus 1, and you write high as just mid, not minus 1 here. So it all depends upon the way you are solving the problem, okay. Sometimes it may be opposite, okay. So it all depends on problem. So I am writing it with min less than max, so you can try to build the logic using min less than equal to max, okay, and then you may need to update your low or high, okay, something, or may not need to update low or high, okay. So just take paper and pen, try to solve any particular example, okay, on paper and pen, and see how you are able to solve. With min less than max you are able to solve, or with min less than equal to max you are able to solve, and with what values you are taking of low, mid plus 1, high min minus 1, or low is equal to mid plus 1, or high is equal to just mid, okay. So and using paper and pen also you can find out what we have to return, whether we have to return low or high, okay. So just practice it. All right, so this is done. All right, so here first, now let's calculate the mid, okay. Normal binary search approach, so is equal to divided by 2. All right, and inside this what we have to write, min plus max. All right, done. And now here let's take long car sum, how many number of cars we can repair in this much mid amount of time, okay. So this, and now just iterate over all the ranks one by one. In the rank, in my ranks, all right, and here I will just update the car sum is nothing but a summation of all the car sums, okay. So here math dot square root, okay, the formula that we have derived, okay. So here what we have to write, we have to write mid divided by rank, okay, and this should be in long, okay, whatever the value I'm writing, it should be in long. Done. All right, and here we have to write the logic. So if my cars sum, okay, if it is greater than equal to cars, that simply means in that case we have to update my max as mid, okay. So in the first half we have to search now, okay, maybe we can do all the cars repair in less amount of time than that, okay. Else if we are not able to do it in mid, then we have to update the range, okay, maximize the range. So in that case my min should be updated to mid plus 1, okay. Now this is done, and in the end just return mid, that's it, okay, return mid. Now let's run the code and see if there any code issues, any spelling mistakes like. So let's see. So yes, there is some issue. So here return, it should be min, not mid, min, okay. Let's run it again, okay. We are returning min. All right, so all the test cases has been accepted. Now let's submit it. Let's see. So see, our solution is accepted, right? So I hope that you guys are able to understand today's problem, and if you guys still have any doubts, then please feel free to ask in comment section. Till then, keep coding and keep practicing. Meet you guys in the next video. Thank you. Bye bye.